All right. All right, so let's move on to the next, I guess, topic, so to say. Here. So before we had an annuity, that was actually called a savings annuity. The idea there, remember, as we saw just before, was, we take some money out, right? And we're going to put it into an account through monthly deposits, before retirement. Again, I'm sure there's other examples besides retirement accounts, but off the top of my head, that's all I can think of when I made up the notes. But here's what we call a payout annuity. This is a little bit different. The idea here is we hit retirement. And now what we're doing is monthly, maybe, or even once a year, we're taking money out of that account. Okay? Money that's left in there is still earning interest. That's still happening, but we're taking money out, though. So it's almost like now we have compounding, but now we're allowing monthly withdrawals. And of course, after some time, the account's going to be empty. Now, does that always happen with retirement? I don't know, but for here, let's just assume that. The whole idea is money comes out for you to live on. So, all right. So I didn't go through a calculation for it, to introduce it, because it's very similar to, the savings annuity. Well, it's not exactly the same, but similar, but this is our formula for it. Notice it's not the same formula. For one, we don't have a balance. We have, how do I say this, a piece of zero here. That's the balance at the very beginning. Okay. Again, PMT is, regular withdrawals as before. But notice here the numerator is a little bit different, right? We have negative NT here. Okay, we have negative NT. R is still the APR in decimal form. N is the number of compounding periods per year. And if I said PMT was payments, I'm sorry, but it's regular withdrawals. That's what's happening. So we're taking money out, but we're doing it on a regular schedule. We're taking money out, once a month or once a year. I don't think although I'm guessing we could probably consider daily, but I don't think the book does that for whatever reason. T is time. And as before, if the compounding frequency is not explicitly stated, which pretty much it's going to be the case for the problems we're going to deal with in this class, but we're basically going to assume the number of compound periods is the number of withdrawals per year. It's kind of like what we did for savings, except instead of monthly deposits, we're doing monthly withdrawals. And yes, we can use that Tvm solver to help us out here. Okay, I don't want to go too fast, so this is our formula. Again, it's in the notes, I sent them out through email. The full collection of notes, I do have to go through and tweak up some things, but I will post it once I can. Okay. And of course, you have the book also. All the stuff's in the book. You should be reading the textbook. A math textbook's not the easiest to read, but it's still something you should do, though. You're not going to get better at it unless you actually do it, so. I had to say it to myself many times when I was an undergrad because I wasn't crazy about reading math. But anyway, so this is with payout annuities. Just like before with annuities alone, really, which is savings annuities, there were many deposits. Now we have many withdrawals. That's when you use a payout annuity, when you have many withdrawals. Okay. Again, here we're taking money out, and the money that's in there is earning interest. All right, but let's do an example of this. So let's say now we retired, okay, from our job doing whatever. We have $500,000 in that account. but we want to be able to take money out for 40 years, okay? Again, this is from the book. I don't know how realistic it is. But let's suppose the account is earning 6% interest. How much can we take out how much can we withdraw each year? Notice I didn't say each month here. I said each year. So we're going to use our formula, our payout annuity formula, okay? The balance initially in the account, right? That's what P sub 0 is, the starting amount. That's $500,000, okay? We want to know how much we can withdraw each year, PMT, right? It's not monthly payments, it's monthly withdrawals. So that's our unknown. The interest rate here, we write it as a decimal for this formula. N is 1 because we're taking out money once a year. Also, the account's going to be compounded once a year. This is going on for 40 years. So we have this wonderful looking formula, okay? And we want to figure out what PMT is. So it's really just basic algebra. Kind of like what we did before, you know, just like before, this denominator, right? We want to bring it up here, and how mathematically can we do that? We multiply both sides by it, just like what I showed before. Let me show it again for fun though. We have 0.06. I guess I can really just write 0.06, not 0.06 over 1. But what the heck? Right, we're doing it on both sides. Oh boy. Okay, that's what we're doing, right? Because now that's going to cancel with this, and it's going to be over here, right? And then we divide by everything on top, as you can see. And that's why it's going to be down here. And what's left over is PMT. That's good. That's what we want. I just moved it to the other side, okay? And so, okay, we have this to solve. You could use a calculator. Sorry, wrong. I went, there we go. Sorry, I pressed the wrong button. Wanted to get this laser thing back, but I clicked the wrong button by mistake. So we want to calculate all of this. You could use a calculator if you want. I mean, I used Excel if I remember correctly. You know, if you need help using Excel or Google Sheets, don't be afraid to ask me. It's really not that bad. You just have to put the equal sign before you type this stuff in. But either way, we get our monthly withdrawal, yearly withdrawals to be this. So we could take out this much each year. Okay. Now that wasn't too bad. Let's solve it using the Tvm Solver. Okay. So that's what I want to solve it with. Let me just go back though and ask. Okay. I hope this makes sense what I did. I hope it didn't go too fast. I mean, the notes I will post as soon as I can. Actually, yeah, so. But let me now do the Tvm Solver with the, okay? So I got to stop sharing for, well, actually, before I share it, let me do this. There we go. But again, this is just the same question here, okay? The only difference now is I'm going to use that Tvm Solver, but we have to get the parameters in there. Notice that PV is negative $500,000. Okay? That's negative. We're not taking it out initially. This is actually unknown. This is what we're looking for. This is what we want. No, excuse me. After the whole process, there's going to be nothing left in the account. So that's why the FV, we set it to be 0. Okay? This is in the account. We don't have it. So that's why we're setting it as negative. I 6%, that's because the account here, well, sorry, the account there was 6%. Let me just double check. Here we go. This is going on for 40 years, and we're making one withdrawal a year. In other words, little n times t, 1 times 40 is 40. Okay. Okay, let me now do this. So now let me get to the, what do you call it, the Tvm Solver. Okay, let me clear it all. So again, our n is 40, 1 times 40. We had a 6. You know, we write that as a, we call it as a percent. PV we're going to have is negative 500,000. Okay. This is what we're looking for. FV is 0. Both of these are 1. There's only one withdrawal a year. Now if we solve for this, we get $33,230.77. So we actually do get the same amount as before. Oh, wait, they can't see. So we do get the same amount as before. This is actually what we had on the slide, $33,230.77. Even if I did make this, what do you call it, positive for whatever reason, you can see it's still going to be the same number, except that's going to be negative. But when you write down your answer, you're not going to put a negative. You just remember, oh, well, it's negative because cash outflows are negative. It's that kind of thing. But we know the answer is 33,230. Hope that makes sense what I'm saying. I know the negatives can be kind of a pain, but I don't think it changes the absolute value of the answer. In other words, when you actually write the answer down, like on a test or something, you're not going to put negative something. You're going to put the number itself. Okay. So we have this. Again, this is what we have. Let me just fix that, though, because this was negative. Again, the PV is negative because that's how much is in the account. We don't have that initially. Okay. We're solving for this. That's what we get. Again, it's withdrawing, so that's going to be cash outflow for us. That's why this is positive, the PMT. All right, let me see. We got time. Okay, so let me actually let me stop recording. Yeah, I better stop.